Have you ever looked at an exam paper and wondered what really separates a good answer from a perfect one? Well, in this explainer, we're going to dive deep into a single 10-mark chemistry question. We're going to pick it apart to figure out exactly what the examiners are looking for so you can lock in every single point. Let's get into it.
Right. This is the big question, isn't it? It's the one that can make all the difference. You might know the science backwards and forwards, but if you can't say it in the exact way the examiner wants to hear it, you're just leaving marks on the table. So today, our mission is to close that gap. We're turning good into great.
Okay, here it is. Our challenge for today, question 5. And this is a biggie. It covers ionic bonding and the nitty-gritty of electrolysis. That's a full 10 marks up for grabs, and you know what? We're going to figure out how to get every single one.
All right, first up is the biggest single chunk of marks in the whole question. We're talking about a 4-marker, and it's all about how that ionic bond gets made.
Okay, let's really look at the wording here. The first thing you've got to notice is that command word, describe. That's your clue. They don't just want facts, they want a step-by-step story of what's going on. And you see that little number? 4 marks. That means we need to make 4 distinct, crystal clear points to get full credit.
So, how do we guarantee those 4 marks? Simple. We speak the examiner's language. And what you're seeing on the screen right now, that is their language. This is the perfect answer, straight from the mark scheme. Let's walk through it. Point 1, you got to say each calcium atom loses 2 electrons. Point 2, each chlorine atom gains 1. Point 3 is key. You have to connect them. 1 calcium needs 2 chlorines. And finally, for that last mark, you have to name the ions that are actually formed. See that flow? It's a logical story. That's what gets you the perfect score.
But you might be wondering, what if you didn't word it exactly like that? Well, there's a little bit of wiggle room. For instance, if you just said something general, like calcium loses electrons and chlorine gains them, you'd still get a mark. Same goes for mentioning that the whole point is to get a full outer shell. But notice something? Those are only worth 1 mark each. The lesson here is so clear. The more specific and precise you are, the more marks you're going to get. So why settle for 1 mark when you know how to get all 4?
Okay, section 2. This is where we pick up the pace a little bit. We've got a series of 3 quick-fire 1-mark questions coming up. These are all about testing your core knowledge of electrolysis. Ready?
First up, question 5.2. You see this kind of question all the time. Why can't we electrolyze solid calcium chloride? It all comes down to one really simple idea: movement.
And here it is, the perfect 1-mark answer. The ions cannot move. That's it. See, in a solid, the ions are all locked up in this rigid structure, so they can't travel to the electrodes to carry the current. The mark scheme also says you can say the ions are in fixed positions. See how short and to the point that is? For 1-mark questions, that's what you want to do. Be direct.
Okay, next up, 5.3. So now we've dissolved the calcium chloride in water, making it aqueous. This changes everything, because now water is part of the mix. So the question is, what gets made at that negative electrode? This is a classic test of your electrolysis rules. And the answer is hydrogen. So why is that? Well, in an aqueous solution, you've got a competition at the negative electrode. You could get calcium metal, or you could get hydrogen gas from the water. And the rule is super simple. The less reactive element wins. Since calcium is way more reactive than hydrogen, it's the hydrogen gas that bubbles off. For your answer, just writing the word hydrogen gets you the mark.
And for the last question in our little quick-fire round, 5.4, we need the half equation for what's happening at the positive electrode, the anode. And this time, it's multiple choice, which is kind of nice.
The correct answer is the one showing 2 chloride ions becoming a chlorine molecule. And how does that happen? Well, they have to lose 2 electrons. You remember that old phrase, right? Leo the lion says jur. Loss of electrons is oxidation. And that's exactly what this equation shows happening at the anode. Perfect.
And here we are, the final part. This one's worth 3 marks, and it's a little different. It's not just about recalling facts. Now we have to actually interpret what we're seeing in an experiment. So time to put on our detective hats.
So, check this out. We start with a single drop of green copper chromate solution. Pretty simple. But the moment we turn on the power, something really cool happens. That green spot splits apart. We get a blue streak moving one way and a yellow streak moving the other. So the big question is, what on earth is going on here?
To get all 3 marks, you need a 3-part explanation. First, you have to explain the colors themselves. The blue color comes from copper ions, and the yellow comes from chromate ions.
Just stating that gets you your first mark. Then, for the next 2 marks, you have to explain why they move. So point 2 is telling them where the blue copper ions go, and point 3 is saying where the yellow chromate ions end up.
And honestly, this whole thing boils down to one of the most fundamental rules in all of chemistry. Opposites attract. It's that simple. The blue copper ions have a positive 2+ charge, so naturally, they're pulled towards the negative electrode. At the same time, the yellow chromate ions have a negative 2- charge, so of course, they get pulled towards the positive electrode. And that simple attraction is what literally pulls the green dot apart.
And just like that, we've done it. We've decoded all 10 marks of question 5. We've seen it all, right? From long descriptions to single-word answers. So, after all that, what's the big lesson here? What's the key takeaway?
You know, this brings us right back to where we started. What really is the secret to turning a good exam into a great one? It's got to be more than just memorizing a bunch of facts, right?
The secret is this 3-part strategy, and it works for pretty much every question you'll ever face. First, you have to understand what the question is asking. Look for those command words. Second, you have to know the science inside and out. But this third part is the one that so many people miss, and it's absolutely crucial. You have to learn to speak the examiner's language. Use those precise scientific keywords that you know are on the marks game. That's not just how you pass, that is how you decode the exam.